Fixed proportional technologies. A fixed proportions production functions is of the form y is equal to minimum a1 x1 a2 into x2 so on an xn. For example, y is equal to minimum x1 and 2x2 in which n is equal to a1 is equal to 1 and a2 is equal to 2. Fixed proportional technologies graph. If x1 is used to 1 unit, then x2 should be used in 2 units and it will give you output the 4 unit. Keep on doubling to inputs, output will be tangent. Perfect substitute technologies. Then there is a perfect substitute production function that appeared with the positive sign in units, and it shows y is equal to a1 x1 plus a2 into x2 plus so on an into xn. a1 and a2 is the coefficient of the perfect substitutions form. Here there is perfect substitute technologies or the straight lines. These are all linear and parallel to each other. That means that they have a fixed slope. Marginal physical product. Now generally when we analyze the production functions, we always more interested in the next unit decision making. So we are not make decision in total, but we decide in terms of marginal term. That means if you add the 1 unit of input, what will be the level of output. This discussion provide help to us through marginal product, and remember that there are the physical product, no price involved. So the marginal product of input I is the basically change in output with respect to change in inputs, holding all other inputs level constant. So if you take the fixed first derivative in slide number 49, typically the marginal product of input 1 and 2. Here there is marginal physical products, then the marginal product of input 1 and marginal product of input 2. Typically, the marginal product of one input depends upon the amount used of other input. If x2 is 8, so how much x1 will be used, and x2 is equal to 27, then how much marginal product will be x1. Both marginal products are diminishing. The next concept, return to scale. Increasing return to scale. Return to scale marginal product describes the change in output level as a single input level change. Return to scale describes how the output level change as all input level change in direct proportions, all inputs level doubled or half. These are the concept of decreasing return to scale. Return to scale, one input, one output. Increasing return to scale, at first we will be discussing. Similarly is the increasing return to scale. If you look at the level of output, so it is increasing with the doubling input level. Return to scale. A single technology can locally exhibit different return to scale. A single technology can different return to scale. Return to scale, one input, one output. This graph shows when the input is the function of a single input, and you can see in the beginning, before the perpendicular dotted line, the green line is rising very fast, and this is increasing return to scale, and after perpendicular, some points it rises is slow and the slope of the curve is getting flatter and flatter. So after dotted line show the diminishing return to scale. Example of return to scale 68. Example of return to scale, the perfect substitute production function, and expand all input level proportionally, the output level become example of return to scale. The perfect complement production function exhibited constant return to scale. Here there is a Cobb-Douglas production function, and expand all input level proportionally by k, the output level becomes the next concept. We will cover the rate of technical substitutions. It's incoming slide. Return to scale. A marginal product is the rate of change of output as one input level increase, holding all other input level fixed. Marginal product diminishing because the other input levels are fixed, so the increasing input units have each less and less of other inputs with which to work. When all inputs level are increased proportionally, there need be no diminutions of marginal productions, since each inputs will always have the same amount of other inputs with which to work. Inputs productivity need to fall and need not fall, and so return to scale can be constant or increasing. So what rate can a firm substitute one input for another without changing its output level? So here there is a concept we will cover, the technical substitution. It's a rate at which firms substitute one input for another without changing its output level. Technical rate of substitution. Graph x1 and x2 are both inputs, and you can observe that the total output does not change. Technical rate of substitution. Here there are question: how is the technical rate of substitution computed? The production function is y is equal to f into x1 and x2. A small change delta in x1 and delta x2 in the input bundle cause a change to the input level of technical rate of substitution is working, assuming that we are remaining at the same isoquant when the delta y is equal to 0. So if you solve it in terms of delta x divided by delta x1, so this will be the technical rate of substitution. You can observe this is a negative sign in last expression. Input 2 must be given up as input 1 increase so as to keep the output level constant. It is the slope of the isoquant and it will be negative. Technical rate of substitution, a Cobb-Douglas production functions example. A well-behaved technology is monotonic and convex also.
Thanks for watching this video. Thank you. Allah Hafiz.